engineering, and particularly projectile motion, throwing, and dropping things. So our first problem in this particular category kicks off with a little bit about the Golden Gate Bridge, bridge in San Francisco, California. It is on my bucket list of places to visit. I just want to see it. Here's hoping I get there someday. But anyway, true story. Each cable joining the two towers on the Golden Gate Bridge can be modeled by this function. Our textbook editors went out and they actually did a little research and found that function does model this cable right in here. Do you see how it's a quadratic function there? It's a parabola hiding in the bridge. And I'll be honest, in my career, I've taught many structural engineers, and maybe you'll be one of them, and you can maybe look back on, these formative days in your math career and be like, yeah, I actually remember looking at things like this. So that'd be pretty cool. So yeah, we see that you have that positive A value. I know it's small. It's 1 over 9,000, so that's a little number. But it is still positive, so we get this smiling sort of parabola hanging out in our graph there. X and Y are both measured in feet, and we're asked to figure out L, which is hiding down here. L is the length above the road of the cable at its lowest point. Ooh, would you see that? Lowest point, aka, friends, the vertex. Okay, so little deviation from our revenue problems. This time around, we're finding the lowest point on the graph. We're going to find that vertex right there. And we can use the diagram below to assist us. Well, I know it's scary, but that's just an equation in standard form. And to find the vertex in standard form, we always start by finding our axis of symmetry. And the formula for our axis of symmetry is just x equals negative b over 2a. Remember, typewritten fractions in the problem mean that your work and your answers should be in fraction form. So the opposite of b in this case is just 7 over 15. And then I got to do the product of 2 times my a value, which is 1 over 9,000. If I simplify the numerator, that's just 7/15. It doesn't really simplify. But if I simplify the denominator, I'm looking at 2 over 9,000 if I multiply straight across there. 2 over 9,000 is just 1 over 4,500. And we don't really ever leave fractions that look like that. So when we divide 7/15 by 1 over 4,500, quick review for you if you're not a fraction fan, we actually have to multiply by the reciprocal of that divisor. So we're going to take 7/15 and we're going to multiply it by 4,500 over 1. So I had to flip this guy and multiply. I think your middle school teachers use some little mnemonic device. What was it? Keep, change, flip? No. Keep, flip. I can't remember what that phrase was. Keep, change, keep, I don't know. But you can go ahead and holler at me next time and let me know what that phrase is. Those crazy cool middle school teachers. Again, my goal is to always never touch a calculator, so until I go to check my work. So what I want you to observe is the fact that, yeah, these are some big numbers, but I can make them a lot smaller. 15 and 4,500 have a common factor of 15. 15 goes into 15 once. 15 goes into 4,500 300 times. So really, I'm just taking 7 times 300. That's going to be 2,100 feet. So what does that represent in this case? That's an x value, right? So basically what we're saying here is that this is 2,100 feet, and this is 2,100 feet, because we just found our axis of symmetry to be at 2,100. So the distance across the bridge is 4,200 feet from those two poles, I should say. That's not what the question asks us, though. The question asks us, what's that length? So to focus our attention again, it's what's this length above the road? You know, like let's say we were driving a truck across this bridge. You know, what's the height that this truck could be before maybe it smashes into the cables there, depending on where these cables are positioned. So we want to figure out, what is that actual minimum value? So again, to find that actual minimum value, we're taking our function and we're going to let our x equal 2100. So we have y equals 1 over 9,000. And then we got x squared, so that'll be 2100 squared minus 7/15 times 2100 plus 500. And you're going to get 10 feet. So that's how far that cable is above the road. That is something. Not very tall. I think those are just off to the side, though, so like literally trucks aren't wailing off those cables every day. That would be bad. To answer the question, 10 feet is the length above the road of the cable at its lowest point. So that would be your sentence. Once again, the sentence you would want to record is that 10 feet is the length above the road of a cable at its lowest point. So it's again restating the question in your answer when you write your sentence. Once again, I went ahead and I put this in my graphing calculator because it's fun. There's my equation. Remember, if you're going to be a person who leans on your calculator and you're typing fractions into your calculator, and you're going to want to quantify those fractions, put them in parentheses. If you don't, your calculator will mess up your day. You'll get a hyperbola. You won't even get anything that looks like a parabola. You'll be super mad. You'll throw your iPad. It'll cost money. It'll be just real, real bad. So don't do that. Just make sure you put your fractions in parentheses, okay? You might be wondering, if you press graph, your graph doesn't look like this. It's because I had to tweak my window, right? So you could zoom fit, or let's go, honors kids. Let's talk about where that window comes from, right? So if you think about what x value stood for in the problem, that was a distance across the bridge. And we figured it was about 4,200 feet on either side. So I just went from 0 to 4,200 by 500s, just because 500 seemed like a nice scale, nice way to break up 4,200. And then your y value was going to be a height of those cables. And even just looking at the picture, you can see that, if I have that picture up there, it's 500 feet up. So I just went up to 1,000 just to give me some space there. And then I get a parabola that kind of matches the picture that we see. And again, because we wanted to know the cable at its lowest point, this time around we can make our calculator calculate the minimum. So I'm going to go ahead, second calc, down to option 3. I'm going to go a little bit to the left of where that minimum should be. I'll go to the right of where that minimum should be, and I'll press enter. And you see that that minimum value there is at 10 feet. So this sort of confirms what we found.